All right, welcome to Chapter 4. This is our graphing chapter. So let me say first and foremost, you need to have graph paper. And we probably already discussed this in class, but even for tonight's homework, you need to have graph paper in front of you because you're going to be creating a lot of coordinate planes. And if you do this on paper other than graph paper, you're probably not going to be setting things up correctly. So make sure that you have graph paper and a pencil ready for this video. Our first section it's a very easy one. It's on coordinates and scatterplots. So we'll briefly review how to plot coordinates. This is something you've done in elementary and middle school. And then we'll do a scatter plot together, talk about best fit lines and interpolation and how to estimate values on a scatter plot. Okay, so let's go ahead and get into it. Coordinate plane is formed by two real number lines that intersect at a right angle. Each point in the plane corresponds to an ordered pair of real numbers. And those two real number lines we call the x-axis and the y-axis, you'll remember. First number in an ordered pair is the x-coordinate, and the second number we call the y-coordinate. And here you can see a coordinate plane with its horizontal x-axis and vertical y-axis, and then the origin in the middle. So it's kind of like a number line, but it's two number lines that are perpendicular to each other. And whenever we write coordinates, remember, we always write them in the form x first, comma, y. So the x value will always precede the y value. And whereas on the number line 0 was the origin, on the coordinate plane the point 0, 0 is going to be the origin, and that's right there at the center. Okay, and I know that you guys already know this stuff, just kind of reviewing here. All right, the x-axis and y-axis divide the coordinate plane into 4 quadrants. To locate the graph of a point, look at the signs of the coordinates. So first thing I want to say is that you have 4 quadrants. We divide the coordinate plane up into these 4 sectors, each sector called a quadrant. And the quadrants go in a counterclockwise fashion. So beginning over here with quadrant 1, we kind of go in this direction to quadrant 2, quadrant 3, quadrant 4, and then back up. So just know that when you count these, you'll go in a counterclockwise direction. And directionality is very important. Notice that for the x-coordinate, it's a choice between left or right. Left is negative, right is positive. For the y-coordinate, it's a choice between up or down. Okay, up is positive and down is negative. And I think that that's pretty intuitive. So over here in quadrant 1, you'll notice that both the x and the y coordinate have positive values. So your x would be positive, causing you to go to the right, and your y would be positive, causing you to go up. And that's how you end up in quadrant 1. Over here in quadrant 2, notice that your x value is negative and your y value is positive. So a negative x value causes you to go to the left, and a positive y value causes you to go up, ending up somewhere in quadrant 2. Quadrant 3, you have both a negative x and a negative y. So starting from the origin, the negative x would cause you to go to the left, and the negative y would cause you to go down into quadrant 3. And lastly, quadrant 4, you have a positive x and a negative y. So the positive x would cause you to go to the right from the origin, and the negative y value would cause you to go down, ending up in quadrant 4. So just make sure that you don't get confused on those. Okay, so let's go ahead and practice. Here's what I want you to do. Take out that graph paper, go ahead and create this coordinate plane. And you'll be able to take your time, make a nice, neat coordinate plane. A good coordinate plane should only take you about 45 seconds to draw. It's a quick x-axis, a quick y-axis using the blue lines of your graph paper. and then you'll want to draw the little hash marks you see also on top of blue lines on your graph paper. And I'll be checking these tomorrow when you turn these in. So make sure that your coordinate planes look nice and neat. And what I want you to do is plot these 4 points and make sure that you put them in the correct place. So I want you to go ahead and hit pause now, create your coordinate plane, plot your 4 points, and then we'll go over answers just to make sure everyone remembers how to plot points correctly. All right, let's see how you did. 2, 3 should be located right there in quadrant 1. Negative 3, 1 should be located right there in quadrant 2. Negative 4, 0 does not belong to any of the quadrants because it's right there on the x-axis. So it should be located right there, negative 4, 0. And then 5, negative 2 should be located right there in quadrant 4. And just as part of good practice, you do need to label these. So if you didn't, you can kind of do this along with me right now. But you want to write the coordinates by the points. And sometimes instead of the coordinates, these might get labels like A, B, C, and D. And then you can write the letter, whatever makes the most sense, whatever you have the space to do. So negative 3, 1. We have negative 4, 0. And then last one, 5, negative 2. So pretty easy stuff. And if for some reason you got confused on this, hopefully that explanation worked for you. If not, just kind of ask me in class. All right, let's move on to scatterplots. So it says one way to analyze relationships between two quantities is to graph the data pairs. This type of graph is called a scatter plot. So typically what we have is we have one type of measurement on the x-axis, one type of measurement on the y-axis, and then we get these data points that are the combination of measurements from both. And here what you're looking at is quite a few graphed points all considered together in what we call a scatter plot. And what we look for in scatter plot, we look for trends. And so if I were to ask you, hey, does it look like this is an upward trend or a downward trend? Well, you read this guy from left to right. So going from left to right, is this going up, is this going down, or is it too hard to tell? And hopefully you see this as going up. I mean, I could even draw a best fit line in here, something like that, to kind of stand for the slope and the direction of the trend that we are observing. Okay, so that's a scatter plot. It sort of helps us see trends between data sets. And what you're going to do right now is you're going to create your own scatter plot. Don't do anything yet. Let me just kind of walk you through this. So it says you are the student manager of the high school hockey team. While putting together the program guide for the team, you record the height and weight of each player and list it in the table below. Okay, you're going to make a scatter plot of the data. Be sure to title, label, and be clear. Okay, and eventually we're going to use this scatter plot to answer these two questions. We're going to estimate the weight of a player that's 69 inches tall, and we're going to estimate or predict the weight of a player who's 74 inches tall. We'll come back to those estimations at the very end. What we want to focus on right now is actually creating a good scatter plot. And I'm going to help you with this. So on your paper, you can use mine as a model. So on the x-axis, we'll have height. On the y-axis, we'll have weight. Notice that on my x-axis, I'm skipping by 2s, 66, 68, 70, for height in inches. And then on my y-axis, I'm skipping by 10s for my weight in pounds. And I should probably label those inches and pounds respectfully. So what I want you to do right now is go ahead and copy this on your graph paper. Make sure it looks nice and neat, and it needs to resemble the one you're looking at on your screen right now. And once you've copied it, go ahead and you're going to hit pause now, and then you'll go ahead and unpause after you've copied it, and I'll go back to the previous slide so that you can plot the points in the correct position. Okay, so go ahead and pause now to create your scatter plot, and then unpause once you're done. Okay, hopefully you're looking at a good scatter, or a good x-axis and y-axis that you've created. Here we're just centered in quadrant 1 because all of our values are going to be positive inches and positive pounds. Let me go ahead and backtrack so now you can look at this data table. So you have your height on top and your weight on the bottom. Remember that your height is your x coordinate and your weight is your y coordinate. So you'll begin by plotting a point at 72, 190, and then 70, 170, so on and so forth until you have points plotted for each player that you see here listed. So go ahead and plot your points now. You can hit pause and then unpause once you have all of your points plotted, and then we'll go from there. Okay, so first let's go ahead and check and make sure that our scatter plots match up. So you can see all of my plotted points right here, and you want to glance and just make sure that your scatter plot is very similar to mine. Okay? All right, now what I want you to do is maybe off to the side, we're going to set up a little place where we're going to answer those two questions from before. So maybe something like question A, and then a blank, and then question B, and then a blank. Something like that. And I'll go ahead and ask you the first question. I want you to use your scatter plot to estimate the weight of a player who is 69 inches tall. Okay, estimate the weight of a player who is 69 inches tall. And then I want you to write down your answer in the blank for question A. So once again, estimate the weight of a player who is 69 inches tall. So go ahead and think about it, pause if you need to, write down your answer, and then unpause. We'll go over the correct answer. Okay, so some of you might have come up with answers like 150, 155 pounds, maybe even 160 pounds, maybe even 165 pounds. And what we want to do is we want to be as precise as possible. So how do we go about doing this? Okay, well, one way, and this is not the preferred method, but don't feel bad if you did this. One way is some of you guys might have come over here to 69 on the number line, and you might have noticed that we had two plots for 69, right? One of these was at 150, and one of these was at 160. And maybe you decided, okay, I'll split the difference between the two of those, and maybe you come up with an answer like 155. And I'm not going to tell you that you're wrong, per se, but I don't think that that's the best answer. And the reason is because you're only considering two of the plots in your whole scatter plot. And believe it or not, the whole entire scatter plot is important. Okay, the whole entire scatter plot shows a trend, okay, and we need to abide by that trend. So before you make an estimation, what you actually want to do is draw what we call a trend line or a line of best fit. And this line of best fit is going to represent your whole scatter plot. Some of the points will fall above it, some of the points will fall below it. So for example, do you think that this would be a good line of best fit? The answer would be no. Sure, we've got some points above it and some points below it, but it doesn't really represent the upward trend of the dots. And the trends do show this positive behavior where they're going up from left to right. Okay, so I don't think that that would be a good trend line. Okay, what about this trend line here? I'm going to say it's not a good one either. Sure, we have some points above, points below, but the slope is a little bit more gradual than what I'm observing in that scatter plot. In other words, that trend line is going up, but it's not going up enough. It's not steep enough. Okay, I think that a better line of best fit would probably be something like this. And this isn't going to be perfect, but this I think will better represent the trend. Maybe something like this. Okay, notice it's going up from left to right. It's as steep as the trend that we observe in the dots. It's kind of like the average positioning. You've got some dots above, some dots below. And this is really what we're going to use to come up with our answer. Okay, so going back to that location, that's 69, we want to see, okay, where will this hit the trend line? And that's really where we want to focus. So it hits the trend line right here, and that's going to be the best estimation. Okay, so that point, if you kind of look to your left, that's roughly at 160. So if you answered 160, I'm going to buy that. So 160 pounds. Okay, let me give you another one to do. For part B, I want you to estimate the weight of a player who is 74 inches tall. Okay, go ahead and estimate the weight of a player who is 74 inches tall and write your answer in the blank for part B. And while you're doing that, I'll fix my axes. I should have written down the units. Weight here is in pounds. Height here is in inches. That always needs to be labeled. All right, what'd you come up with? Well, if you don't have your own best fit line, you need to draw your best fit line. And your best fit line might not be exactly the same as mine, but we should come up with a similar answer. Okay, so 74-inch player, and I'm going to look at where that crosses my best fit line. And then I'm going to go through this process of seeing, okay, where do I think that value lies on the y-axis? Okay, it looks like it's a little bit above 190, a little bit below 200. And so I'm going to have to kind of estimate, okay, where do I think that, you know, where does that fall? Is it at 195? Is it a little bit less than 195? Okay, I'm going to place mine about right here. And we might get different answers here. I'm coming up with 192 pounds. You might not have had that. And if this were a test, I'd probably accept anything between 190 and 195. So you're going to have to be precise enough to fall within range of what I'm coming up with. And I do want to note the process we just used here. Okay, notice I had two values, the 200 and the 190. Okay, two values, and I was guessing in between those values. And whenever we do this, we call it interpolation. Inter meaning between, and pole actually kind of meaning a pole, like this is a pole, that's a number, and this 190 is also a pole, like a pole here and a pole here, and we're literally guessing the number in between the poles. Okay, so whenever we guess in between any two known values, we interpolate, and that's called interpolation. We did it down here too, with the 68 and the 70, right? When we had to put halfway to come up with the number for 69, that was an interpolated value. We know that 69 is exactly in between 68 and 70. So that's a vocabulary word that you will need to know. And hopefully you understand how to use the best fit line to give the best estimation. That's it for tonight. Pretty short lesson. Make sure you have graph paper, because on your assignment you're going to be creating some scatter plots and you're going to have to plot some points, that type of thing. All right, good job.